Oh no, this is down. I have a setup for that. Hello, hello. 1 2 1 2. Yeah, I think this will work. All right, everybody. Let me know if you can hear me. Hello, hello. 1 2 1 2. Hello, hello. All right. All right. Jen, apologies here, but I think I had to change the setup here, and now they just wrote me it's working. So, apologies. Can you just restart? All right. Thank you. Yes, they're saying, yeah, they do. Yeah. Let me make sure you can hear Jan. Can you hear Jan? All right. Okay. Yeah, she will start in a minute. She will start minute. Ready when you are, Jen.
That people can feel bad if they don't always understand the numbers. Now, sometimes the numbers are harder to understand and interpret than you might think. So what's the agenda for today? We are going to look at the concept of a HiPPo, the highest paid person's opinion, which is usually the boss, and their opinion goes. Can you use data science to persuade the HiPPo of the value of your project? Here's an example of Anscombe's productivity. You can see that the data looks really different for each of these 4 datasets. What we do that the 4 datasets have actually got the same summary statistics, the same mean, the same variance, and the same median. However, the data is plotted extremely differently. So sometimes we need to use data visualization as well as statistics in order to understand the data. So let me give you an example. This correlation looks great, doesn't it? You can see that the pink line and the black line follow each other very closely. So you must be wondering, what are these two items? What do they represent? Is there a clear relationship between them? However, it's not correct. What we see is that the data in pink shows the number of letters in a winning word of the Scripps US National Spelling Bee. And that's been plotted with the number of people killed by venomous spiders. So now we understand the context of the data. We understand that contextually there's no relationship between these numbers. Instead, they have been plotted in order to show that it looks on the surface as if there is a relationship, but in fact there's not. So statistics is not well understood by many people, and here are some examples. In the bottom left-hand side, we see on the y-axis the amount of hope left for the human race is inversely corresponding to the number of people who wear Crocs. I'm sure that's not true, but for some people it seems as if we can put anything on a chart. You can see some quotes here, and this doesn't make any sense from Bill Clinton. Every American should have above average income, and my administration is going to see that they get it. However, if everything was above average, it would no longer be average anymore. So it doesn't make sense. And from the other side of the fence, here is a quote from George W. Bush. And he says, "It's clearly a budget. It's got lots of numbers in it." Then in the top right-hand side, we can see a headline that says, "Statistics show that teen pregnancy drops off significantly after age 25. Well, funnily enough, if someone is expecting a baby at the age of 25, they're no longer a teenager. So the headline does not make any sense. So how can we find patterns in the data? And how can we make sure that we are expressing and exploring the patterns in the data effectively? One item we can look at is how can we model the data? Here, we are trying to understand how we can model the data, which really means how can we build a pattern on the data, and how can we use that lens in order to predict the next step for the data. Here is an example of regression. In the example of regression, we are trying to fit a line of best fit throughout the data. In this example, perhaps regression is not the best way to understand the data. We can see two clusters. This may mean we can try to work and understand better the data by looking at it in different ways. In this example, we are modeling the data using decision trees. The very first point at the top is the starting point. And then we can use the branches of the tree in order to form a decision. This forms a route for the data to go down. Now, decision trees are very popular with business people because they are very easy to understand. Here is an example of a neural network. With a neural network, we start with a lot of input nodes, and we are trying to summarize the data down to a few output nodes. So the magic happens between the input nodes and the output nodes. Sometimes the mathematics for the neural net itself are very complex to understand. From the HiPPo's point of view, this can be difficult to understand, which means that they do not trust it, even if it has good results. This is why AI explainability is a very important concept. Explainability helps us to translate the meaning of the model so that it can be used for our data and also used to predict in order to find other explanations. Here is an example of clustering in the data. We can see our data forms 3 different clusters. This is the iris dataset, which is a very well-known dataset in data science. If you are interested in learning data science, you will find that the iris dataset is one of the most popular datasets. So what does your HiPPo care about? Let's have a look at some of the calculations. Now, statistics is an important part of business. It may appear in parts of the business that you may not see it has a natural home. One example is marketing. Believe it or not, marketing contains a lot of statistics. For example, if you are doing some marketing and you want to classify and categorize your customers, you can use statistics in order to do that. You can also use statistics in marketing in order to understand concepts such as consumer spending patterns. Secondly, management consulting is all about the efficient use of resources in an organization. With statistics, it can help you to understand better if the resources are being used efficiently. A third place for statistics in a business is website design. Website design is one way in which statistics can help determine how efficient your website is. For example, is it capturing more people after some changes? Or you may do some A/B testing, for example, to identify what is the best for you. So when we are examining our data, we are interested in the center of the data and the spread of the data. For example, is the data skewed around, does the data gather around the center when we plot it? Is it widely spread? Or is the data congregated just in one part with lots of outliers? This is interesting when we start to look at statistics. We need to understand better the shape of the data. For example, does it appear like a normal curve, for example? If it doesn't, we may need to take that into account when we are trying to understand better how our statistics looks. It may also help us to choose which statistical tests we are going to use. Now, these are very familiar measures of central tendency, and we do these ones in school. For example, we like to know the mean, which is the average. We also like to know the median and the mode. These numbers may differ from one another depending on the center and the spread of the data. With that in mind, we are interested in the measures of dispersion, and we try to understand these before we move forward to model the data. For example, we need to consider the spread of the data, and that's what the variance tells us. We also want to understand how the percentiles look. If we see that our dataset is divided into 100 equal parts, how does that look when we try to plot it? Is it unequally spread, for example? We also need to think about some specific calculations. An important calculation is return on investment. We don't need to calculate this using Azure ML or R even. We can calculate this with Excel. So price is what we pay, but value is what we get. That's a quote from Warren Buffett, and I believe he's correct. With data science, we're often thinking, how do we do this? How do we find the magic in the numbers? We need to have faith, hope, rigorous testing, and sometimes a little pixie dust, which is data visualization, to help us to make the results nice and clear. So the return on investment really says, if I spend this much, how much will I get back? It's basically asking the question, is this worth our time? It's a measure of a point at time, and we want to know the point at which we start to see that we have made some value from our investment. That's called the break-even point. We need to measure the point at which we make a loss and try to understand it with the point at which we make a profit. Ideally, when we do a project, we want to be in the right-hand side of the chart as soon as possible. We want to cross that break-even point as quickly as possible. So we also have net present value. Say, for example, we want to consider whether to make an investment in buying some property. We could look at what the property costs now, and we could use net present value to understand the value of the property in 5 or 10 years' time. And that would tell us the difference between the present value now and the cash value at the end. And we can do various modelings to understand what scenario that looks like. So the formula for the net present value is given here, and it uses the cash inflow during the specified time period, and it works out the initial investment costs, and it splits it up over time periods and tries to understand how the value of money changes over that period of time. So how can we use Pixie Dust as well? Data visualization is a very important way in order to understand data. We also need to understand data, what people are interested in based on the data. Are you getting some feedback? Sorry, I'm getting some feedback. Okay. Yeah, could you mute yourself, please? I think I'm getting some feedback from you. I just heard some noise or something in the background. I wondered if you could mute yourself. It's coming through in my speaker. Thank you. So we need to think about how we can have some return on investment calculations that people can understand. I'm going to move towards a demo shortly, but I have some more concepts to share with you first. So when we do statistical modelling, we put forward a theory. Now that means that we have one or two samples of data and a hypothesis. And we want to judge whether the hypothesis is true or false. If we say that nothing has happened and there's no difference in our data, then that means we have shown the null hypothesis. However, if we find the alternative hypothesis, this shows that something did happen. So when we do some statistics for business decision making, we set out a strategy. We set out to show that something happened. Normally, if, say, for example, we want to understand if website changes are better, we can do A/B testing, and we may want to show and compare how the website compares with each other. So we look at the distribution of the data, and that means we want to understand if it is a normal curve or not. When we have looked at the distribution of the data, we can then choose a test statistic. For example, we could look at the probability value. That would help us to understand our data better. So, what do we need to install when we start to work with R and AutoML? First of all, we need to install R, and then we can install RStudio. With Azure ML and AutoML, which is automated machine learning, and it's a part of Azure ML, we do not need to install anything because it is all part of the browser. So let's look at an example. I don't know if you've ever tried a pint of Guinness. You may know that Guinness is based in Ireland, and there's a theory about Guinness. The idea is that Guinness tastes better in Ireland than it does anywhere else in the world. Now, interestingly enough, you can use a small statistical test known as the t-test in order to explore that theory. So you could look at the test data for Ireland and the Guinness tasted in Ireland, and you could compare that with the taste data for Guinness when it is being created and drunk somewhere else. So you're comparing two things. You're comparing the taste for Guinness in Ireland versus the taste for Guinness in other parts of the world. So the t-test helps us to do that. And it was invented by William Gossett, who you see here. Gossett invented the t-test, and he did that in order to assess very small grain pieces to understand and produce the best Guinness based on the best ingredients. And that's what the t-test was originally for. So the t-test takes two sets of data and it calculates the mean, and then it calculates the variance and the standard deviation. It's comparing one group against the other. And in our Guinness example, it's going to compare the Guinness tasting in Ireland versus the Guinness tasting in the rest of the world. And the t-test does a sophisticated test that helps us to understand if the mean of both sets of data are significantly different. If the mean of the two groups is the same, then there's no real difference. If they are statistically different, then that says there's something different between the two groups. So the t-test allows us to look at data from Ireland. In this example, it's comparing Guinness in Ireland versus Guinness in the rest of the world. And in our example, we want the probability to be less than 5% to show a difference between the two groups. So I'm going to show you how that looks when we look at R. So in case you've not seen this before, this is RStudio, and we can use this in order to run R. On the left-hand side here, you can see some code, and I will walk you through that code in a moment. On the left-hand side here, you can see our results. I've been running some examples, and these are where the results are found. We can also plot the data, and that will appear here on the right-hand side. And we can see we have variables here, one for Guinness, and here is what the Guinness data looks like. We have a column for Ireland and a column for the rest of the world. These are just taste tests. The idea being that you taste the Guinness in Ireland and you compare it with the Guinness in the rest of the world. And each of these rows represents a pint that someone has had in Ireland versus a pint of Guinness that someone has consumed elsewhere in the world. So we can have a look at this data as well. So we could plot all of that data in Power BI and see how it looks. But what we can do is have a look at this data in R. Now this little bit of code here is simply going to tell us how many rows and how many columns. Yep. Yes, hello? All right, I'll try and do that. Okay, so this is a little bit of code here, which okay, is that better? Okay, so is everyone all right now? And before I proceed, does anyone have any questions? I can't see the chat window, so I'm just. Okay, that's fine. So the way that RStudio works is we can type our code in here. Now I'll mark the comment in yellow, and you can see the comment appear here. The actual code is highlighted in blue. We can select our code then hit Control Enter. And this gives us just a very small chart of all of the data that we see. But we are going to examine this in more detail. So we can use this dim command in order to specify dimensions, which is the number of rows and the number of columns in our dataset. This is a good test because it allows us to make sure that we have all of our data. So you can see right down the bottom that the results are highlighted in red. We have 61 rows here, and we have 2 columns. And any comments, which I will mark in green, are given when we have the hash here. And anything else in blue that's going to give us the opportunity to run code. So that's how the code actually looks. Anything with a hash or a pound in front of it will be marked with a pound sign, a hash, like here. Any actual line of code is in blue at the bottom, and the results, which are marked in red, are also located in black ink. So what we can do now is we can have a summary of the data. So I can highlight the line, and then I can hit run over here, and then we start to see that we can get some descriptive summary statistics of our data. So you can see a summary. You can see a column for Ireland and another column for the rest of the world. So when we look at the statistics, we can see that the mean is quite different for each of these columns. We can look at that more closely using the t-test. The t-test will help us to understand if our two columns of data are significantly different from each other. We can also see some more descriptive statistics. For example, I will mark the min in yellow. So we can see the min is quite different, and the max as well. You see a number of NAs down here, and that simply means there's nothing in them. It's equivalent to a null in SQL Server. You can also work out the standard deviations for Guinness in Ireland. So we don't get any data for that. We can start to change the data in order to get a result. But what I'm interested in here is that we don't get a result because some of the data in that column is NA. And that means that R will not calculate the standard deviations because of the nulls. What we can do with R is we can set up a new column on the fly. This column is going to be called Ireland No Nulls, and you can see that here. So we set up a new column that has no data, that has only data in it, and we remove the nulls. We do that using this particular formula here is NA, and we're using a naught, and the naught is the exclamation mark that we see at the right hand side. And what this means altogether is that all of this together, all of the data that is not null in the Guinness Ireland column, it's been set to a new column that you can see here. So now we can run those commands again. So this time we get data, we get a summary, and we see that we've got some information down the bottom. And we can carry out a t-test here. So what the t-test is going to do is it's going to calculate the mean of the Ireland column and the mean of the rest of the world column. And it's going to compare them to see if they're statistically different from each other. So what we do is we find that they are different from each other. The p-value is tiny. So that means that we have found our alternate hypothesis. What this means is that the means in the data sets and the means in each column are significantly different from each other. So when we apply that to our theory, what we are saying is that the Guinness in Ireland tastes differently from the Guinness in the rest of the world. And you can see the mean calculations being given down the bottom. Now, R is very clever. It will go off and do the statistics for you if you give it the command that you can see highlighted in red here. So that's a tour of R. I know I've used a funny example with Guinness in Ireland, but hopefully to summarise, the concepts are clear. We are using statistics and applying that to a theory. And when we do that, it can tell us something quite powerful about our data. I'm just going to go back to my slide deck. Okay, so to summarize, the researchers concluded that Guinness served in Ireland is significantly better than pints served elsewhere. So it's a good tool, and it helps us to understand better if there are differences or similarities between the two groups. And in this example, we're using it to identify whether Guinness is better in Ireland than it is outside of Ireland. So that's a very simple test, but there are some other calculations which we can apply to real business problems. And these will help us to be more confident about what we find in the data. And we'll also look at ways that we can use these calculations in order to become accustomed to using them in discussions with our executives and our decision makers. So we have a simple example of linear regression. That could be height and weight. For example, using someone's height in order to predict their weight. In multiple regression, it's much more cognizant of how messy life can be. In life, we don't often find that one thing directly causes another thing. Usually, it's a number of variables. And here, the criterion is predicted by 2 or more variables. So multiple regression means that we could use lots of different variables in order to predict a result. For example, in this quick example, people are wondering if someone's extroversion is related to the amount of sales dollars that they make in a week. So we can start to find different variables and try to break down our business questions into things that we can examine, as long as we have got good, clean data in order to do that. What we're trying to do when we are building models is to calculate the residuals. Sometimes this is known as the error. It's a bit like a dartboard. With our models and finding our patterns in the data, we want to hit the bullseye, which is the dot right in the middle. But what we sometimes find is that we don't always hit the middle. So we need to interpret our results a bit better. So the residuals can sometimes mean that we can compute different results in order to understand better how they look. We can also use other statistics as well, such as min-max, and that can rescale different variables between 0 and 1. That means that some of the other variables are not drowning out the impact made by other variables. So when we look at Azure ML, it has ways that help us to understand how efficient our models can be. So we will look at an example in a moment, but we have some modeling there that will help us to understand better how we can measure the efficiency of our results. So you can find lots of examples that perhaps look a little bit confusing, but often what we're trying to do at root is try to understand better the value at the right-hand side, and that tells us how often the p-value is a probability that we find one result and another. So what we can do is try and understand better the p-value and how that is created and how it's understood. So the p-value helps us to understand the significance level. How significant is that difference? So for example, what we have here, sometimes for psychology, we want to say something like the p-value should be 1 in 20 or 5%. So when we look at 5%, we want to understand that we can account for most of the cases for the reason that we think it is. But if not, then what we need to do is say that the null hypothesis prevails. So we're interested in the p-value very often. So here we have an example of another statistic called the F statistic. It's a value that is trying to unpick better what variables account for the result. So with this particular example, we are trying to understand if two populations are significantly different from one another. So the t-test will tell you if one variable is statistically significant. And we saw that with Guinness. Basically, we use the taste for Guinness. But the f-test will use lots of variables, not just one column like we did. We had one column for Ireland and one column for the rest of the world. But we may have had other variables in there, such as quality of water or the amount of lime scale in water. All of these things that could have made a difference to get the outcome that we received. So a good place to start is the f-test. And what we do there is take a lot of data, different columns, and then we try and understand better how those columns produce the results that we find. The f-test will show us if the variables work together and are jointly significant. But if we find that none of the variables are significant at all, it means we need to rethink our test. So we've also got RMSE, and it measures how accurately the model predicts the response. So it's very good for working out things like prediction and trying to understand better how the variables fit with one another. We've also got model validation. And what that is going to do is going to try and understand better the residuals that we talked about earlier. So when we started to look at the residuals, we were trying to understand how far away the result is from where we expected it to be. And that's what this chart is showing. It's showing the actuals versus the residuals, or the fitted result. It's trying to fit a line so we can see how far away they are from each other. So how far away is our dart from the bullseye? And that's what this particular line is showing. So here we've got quantile plots, and what they're trying to do is work out whether the data is normally distributed or if there's a lot of outliers. So that's something that can be quite interesting. Outliers can be the start of a trend. So sometimes businesses are really interested in trying to understand the model validation or the quantile plots as it's discussed here. So this is just an example how we compare the plots against one another to understand better how well the data fits the normal distribution. If it doesn't, it could be an outlier, and that in itself could be interesting. So how do we interpret the results? For example, if we are looking at fitted values here, and that's showing the square root of the standardized error or the residuals, basically the square root of the difference between the bullseye and the actual point. And that's helping us to understand how far away our bullseye is from where we need it to be. So we've also got Cook's distance. It's slightly different. What it's trying to do is measure the importance of each observation to the regression line. When we translate this to our dartboard, what this actually means is the importance of our dart. And when you look at all the darts on the dartboard, are some darts more important than others in trying to work out the regression line? If so, which points are the most important ones? That can help us to understand if there are outliers as well, so it's a good thing to have a look at. Okay, so far we have looked at a summary of the highest paid person's opinion, and we've had a look at how we can explore some business theories using R and using some of the numbers. We've got a little bit of time left. So let's have a quick look at Azure Machine Learning. And if you're interested in following up more, please do look at the R and data mining reference here, which has some examples and great case studies by this gentleman here. It's free to download. So if you're interested in learning more about R, I can recommend this. So how can we look at for Azure ML? So what I'm going to do is I'm going to stop sharing for a moment, and I'm going to log into Azure ML, and then I'll share my screen again. Right. So when we look at Azure ML, you can sign up for free for 8 hours here. This allows you to try it out. So what we can do is we don't have an Azure subscription, so we could go and try this out. And this will allow us to start using Azure Machine Learning. So what we could do is sign up here for an 8-hour trial. And you can see there are some experiments here that you can try. This would give you a good starting point to understand Azure ML better. So you can see we have no experiments here. We've just set this up. There are some sample data sets. So when we click on data sets at the left-hand side, you can see samples here. So that gives us lots of sample data sets in order to work with. But how can we get started? Well, when we click on New, right down the bottom, we can click on Experiment, and there are lots of examples in the gallery just here. So for example, we could use Azure Machine Learning in order to understand, for example, clustering in Iris. So let's have a look at this one. What this will do is it will help us to have a look at whether we can find clusters of iris types based on the length and the width of the iris petals. So when we start to use iris here, This gives us a ready-baked Azure machine learning experiment to use as an example. You can set up your own, of course, but it's a good way to learn how to get started. All we do is drag and drop the items that we need from the left-hand side. So, for example, if I want to add in some descriptive statistics here too, I can drag and drop the module from the left-hand side, and then I can connect it. So what I could do now is I can walk through this experiment and then run it. So we're reading data from a repository, and you can see the data set is given here. So to see the data set, we can click on the URL and we can then save it. It's in CSV format, and the second thing we could do is clean any missing data. I know this data set and there's no missing data in it, but if we did have some missing data, we could go ahead and remove it. Alternatively, we could try to take a guess at the missing data, and Azure ML could populate that data for us. We could also edit metadata. That means we could change column names of the inputs data, for example. And we need to split the data into training and a test set. With a training data set, we can use that in order to try different ways of analysing it in order to find the pattern or the model that best explains the data. Once we've done that, we could then train the data using the pre-baked model that Azure ML sets up for us. This is a clustering model. We are trying to assess the data to see if we can find any clusters. So I'm going to run this experiment, and then we can see the experiment in action. So we can see the experiment properties here, and it's been queued. And that means that Azure is setting up the resources available for us to run our experiment. So we can see some of the modules here have got hits against them. So that means that those have been successfully run. So in this example, the iris data has been cleaned of any missing data, and it's sitting in here at the moment. Now that my screen is refreshed, you can see quite a few of these modules, drag and drop modules, have been left to work. So at the moment, the data has been assigned to clusters, and the experiment is finished running. You can see that here. So what we then find is we've run all of the data experiment, and we can see our results down here. The data is assigned to clusters, and if you want to see the results, we can click in the end of the modules here and then click on Visualize. So the system has found two main clusters. It's found one large cluster and then a lesser cluster here. So what we need to do is perhaps go back and rerun our experiment to find different clusters. We can also work out the columns in the dataset, and we can visualize the results there. So we have found that for these types, they've been assigned the label number 1. These are assigned the label number 0. And there's lots of 1s and 0s in here. And basically what it's trying to do is assign the iris to its type. So we've got 3 unique values, and then we've got the assignments. And that's these assignments, 1 and 0, match the cluster that we saw here. So if this was real life, I'd want to go back and play with the clusters, because we shouldn't really find just one big cluster. There must be other clusters in there. But at least with Azure Machine Learning, you can get some good experiments to get you started, and then you can play with that and see that it works with ingesting data. And then you can see the properties as well of each of these. Okay. So I could save this, and then I could set up a web service so I could deploy it to production. And then I could write some .NET code that would call the model and return results to the model. I could also publish this to the main Azure Machine Learning gallery as well, if I like. So, yes? It certainly can. So if you want to use something like Python, you could add in a Python module if you like. So it's not available because I'm in the trial, but you could use Python or you could use an R script here. And that would allow you to add in your R and your Python code. So in our example, if I wanted to analyze the Guinness data further, I could add in my R code and then put that into the R script and upload the data set here. So if I want to upload the data set, I could just go to New, Data Set, and then upload that from a local file. So you can add in your own custom modules if you like, or you can use the pre-baked ones. So I hope that answers the question. If you use R and Python, then using Azure ML will allow you to apply the power of big data and the power of the cloud to your data science efforts. And I think that would be a good thing. So with that, we are nearly on time to end. So I'm just going to pause before you sign off to see if there are any questions. That's fine, no problem. Okay, thank you. Okay. Well, perhaps we can call the meeting to a close, but thank you very much for having me. My pleasure to come back for another session, another time, if you're looking for another speaker. And thank you for looking after me so well. Thank you for your kindness. Good, I'm glad. Thank you.
All right, everybody. Thank you very much, and also again thank Jen for making time on her busy schedule to come over and deliver us this great presentation, which is the convincing your HiPPo business statistics for AI and data science. I hope you all enjoyed, and I look forward to having you all being present on our future events. And we will talk to Jen. She has an opportunity in the future to come back and deliver another great presentation. I see that no one has any more questions. With that, I would like to close here for today. You all have a great day out there. Be safe and stay well. Thank you all. And and we'll be editing the video and making it available soon enough. Take care, you all. All right, Jen. Thank you very much.
Thank you so much. I'll let you go and enjoy your day. Thank you for your help, and that was great. Thank you.
And I apologize there for the disconnect. I thought it would be on the Gmail, so I'm there sitting and I did all the configuration for that. So I really apologize. I can tell you that will be a lot better for the